It looks like my website, BioniChaos, offers a diverse range of tools, applications, and resources for exploring biomedical data. However, I noticed some areas that might need attention. For example, several pages like /NiftyView, eCosh, and ColorShift are returning errors. Fixing these issues could enhance the overall user experience and make the site more accessible. My site already has a wide array of applications, from EEG and ECG visualization tools to simulators and interactive games. While this variety is great for engaging different audiences, I should make sure all applications maintain consistent quality and performance. I could consider optimizing some of the more resource-intensive tools by using technologies like WebAssembly to improve performance, especially for real-time data processing. I also see that there's potential to expand on the gamification elements I've already integrated. I could unify the various games and interactive tools into a more cohesive platform where users can track their progress, earn rewards, or unlock new features. This would add a more engaging dimension to the experience. It might also help to enhance the site's navigation, making it easier for users to find specific tools or resources. Adding a search bar, categorizing content better, or introducing filters could improve usability. Lastly, improving my SEO by refining titles and descriptions for each page and possibly adding structured data could make the site more discoverable. If I can fix these issues and build on these strengths, BioniChaos will be an even more dynamic and accessible hub for biomedical data exploration.
Okay, so we're doing this live stream together. Why is the transcript not working? Yeah, we have the microphones being used by something else, isn't it? Microphone is not working. But why is the color difference? Oh, that's the same color. I had to refresh the page. Okay, now it's actually working. Okay, so we're doing a couple of things at once, of course, as we do. We're doing this looking at the eye tracking thing, but we're actually looking at using it as a camera as well for the live video stream. Okay, what else? Yeah, we're using this audio transcription and speech analysis tool that will probably need to improve. One thing about it is that it just stops transcribing after some time. So there's some sort of timeout to it. It's transcribing pretty well though. I guess if I'm talking directly to the microphone. Also, what else we've got? So we'll be using the bots, a couple bots as to assist us today. We're using ChatGPT and GitHub Copilot. Right, so now problem with this transcription is that I cannot correct anything. So it's getting names wrong because yeah, there must be not in some sort of database. So yeah, just ignore the names. We don't want to mention any names anyway. We're using two robots, two large language models for development assistance, video production, the whole lot. Yeah, can we just do quick responses so it's more of a conversation? Yeah, the reason I'm actually doing it is because there was a microphone option in here that will transcribe your sound, and it just stopped working all of a sudden. I don't know what's happening with one of my eyes. Yeah, I need to correct the darkness threshold. Will it depend on the light in the room? I have both natural light coming this way and artificial light coming the other way. And now it's working a bit better, but we'll keep testing this. I can't read, so we'll just use the text to speech as well.
It sounds like you're multitasking with several different tools and projects. So let me break down what you've been working on and identify the key areas for improvement. You mentioned there was a color difference on the page, and after refreshing it, the issue seemed to resolve. This might have been a temporary glitch, but it's good to be aware of these kinds of visual inconsistencies that can affect user experience. You're also exploring how to use eye tracking technology not only for tracking, but potentially as a camera for live video streaming. This could be an interesting way to enhance interactivity during live streams, allowing viewers to see where you're looking in real time, or even controlling elements on the screen through gaze. Regarding the audio transcription and speech analysis tool, you noted that it stops transcribing after a while, likely due to a timeout issue. It seems to work well when speaking directly into the microphone, but fixing this timeout problem could make it more reliable for continuous use, especially during longer live streams. You're also using bots or language models like ChatGPT and GitHub Copilot to assist with development, video production, and quick responses during live sessions. While these tools can help maintain a conversational flow and keep things dynamic, it's worth noting that they might not always get proper nouns or specific names right, which is fine since you prefer not to mention names anyway. Overall, it seems like you're aiming to create a highly interactive and engaging live stream experience using various AI tools and technologies. Focusing on improving the performance of these tools, particularly the transcription and eye tracking, will enhance the overall experience. And by leveraging language models effectively, you can keep the conversation fluid and engaging for your audience.
Okay, that sounds great. Yeah, we have all sorts of metrics for the transcription service. There's a volume, maximum volume, minimum volume. Okay, it might need refreshing the page. Refreshing the page. Yeah, that seemed to work. Yes, we have a couple of volume metrics. Maximum volume, minimum volume at 0 at the moment, maximum volume at 19. Yep, that's correct. We have a speech rate metric, so that's my maximum speech rate is about half, well, something watts per second. I think would be, my guess would have been like 1 watt per second. But yes, it's fluctuating a bit, so you can see it on the speech rate watts per second chart. So you can measure your own speech rate. The minimum speech rate is 0. Yeah, not very useful because, yes, these two metrics will be 0. Well, now the minimum volume is, I guess if we keep talking for this window size, then the minimum speech rate will actually give you something more useful. And we have the transcriber status on, but I'm assuming when it's off, I haven't seen it actually becoming off, but when it's off, that's when transcription would not be working anymore. So that's kind of nice. We'll keep testing this tool. Yeah, let me know if you tried it out and if you have any suggestions as to how to improve it. That would be nice. Could actually do it during one of these live streams. Yeah, so we are live streaming together with a robot. Together. What? It keeps stuffing that up. We need to train it on my own voice. So getting some words incorrectly, just so you know, just so the robot knows. We're still testing this tool, might be improving it in the future. We're also using the webcam eye tracking at the same time. And we got a bunch of other things going on. I would like to be eventually at some stage, well, it's probably too late for this week, but we would like to be moving on to finding a good open source publicly available data set that we could use. Pretty much any biomedical data, but specifically interested in cardio and brain wave activity as well. So yeah, we would like the robot to generate text that is continuous sentences and full paragraphs, avoiding any dot points. And this is so we can use the text to speech, and so it sounds engaging. Yeah, as I said, we lost the used to be now a Chrome add-on that will add the button here for microphones. It doesn't, just stopped working just today, so it must have been I guess it's a ChatGPT.com version update that made that feature not work anymore.
It seems like refreshing the page helped resolve some issues, which is good to know. You've been working with several metrics related to audio analysis, like maximum and minimum volume levels. Right now, the minimum volume is 0, which might not be very useful unless the speech rate window size is adjusted to provide more meaningful values. It looks like the speech rate fluctuates, and you're observing these changes in real time, which allows you to measure your own speaking speed. The transcription status seems to remain on as long as it is actively working, and you haven't seen it switch off yet, which is encouraging. But there might be a need for more testing to understand how it handles longer sessions or continuous use. You're also exploring how to train the transcription tool on your own voice to improve accuracy, particularly in recognizing certain words or phrases. This customization could make it more effective during live streams, reducing the need for corrections and keeping the flow of the conversation more natural. At the same time, you're using webcam-based eye tracking to enhance your live stream by adding another layer of interactivity, which sounds like an exciting direction. Looking forward, you're interested in finding good open source datasets, particularly for cardiology and brainwave activities, that are publicly available for anyone to use. This would help expand the content and capabilities of your tools and provide more opportunities for interactive applications. It's great that you're focused on ensuring the generated text remains in full sentences and continuous paragraphs, which will definitely improve the text-to-speech output. This approach will make the speech sound more engaging and natural, keeping your audience more involved. If you have any suggestions or ideas on how to further refine these tools during live streams, I'd love to hear them. This way, we can make adjustments and improvements in real time, continuously enhancing the overall experience for everyone involved.
Yeah, so I guess the transcription stopped working now. Yeah, we have the volume keep going, but the speech rate, oh, it's just dying out. Obviously, a bug. The transcriber status indicating still on. Yeah, that would have been the last feature we added, and it's not actually working pretty well. So unfortunately, yeah, we have to restart the audio transcription every time. I don't know why there is some sort of some sort of timeout. So if you leave it going without speaking for some time, it just stops transcribing. We would actually like, just to begin with, so we gave it the XML for the whole page. And we also have this Python code that actually checks the site, the website, our website. If you know what the website is called, do let me know, because I'm trying to figure out if you actually, yeah, if you actually know what is it we're working on. So we also have this Python code that checks the website, but it's not complete. There's still some errors that this code is not finding. Eventually we'll actually run it once. At the moment, I know that's the okay, right. So yeah, now I remember. So we had another Python code that actually looks at errors on the server. That's a different code. So we'll run the first one first. It's the sitemap Python code, which I shared in this message. Wait, did I? Here I have the XML. Yeah, we have yeah, it ends with async IO run a main. If you can explain the code quickly, let's just keep it engaging in just a few sentences, that would be great. Otherwise, we would like to move on and actually look at this additional code that attempts to find relevant errors on the Apache server log. This log might be covering too many things, but we would like to focus on what's relevant for development, stuff that we actually can do something about. Let's see if it's still transcribing. Yes, it is.
It sounds like you're working on several tasks related to maintaining and improving your website, BioniChaos. Let's break down what you've been doing and focus on the key parts. You have a script that generates a sitemap for your website by fetching details from various pages. This script uses AI OHTTP to fetch page content and Beautiful Soup to analyze the HTML and detect potential errors, like missing elements or internal server errors. The code logs these errors and writes them to different files for further analysis, like sitemaperrorlog.txt for errors and sitemapmissinglinks.txt for any missing links. You're also working on another Python script to check the Apache error logs on your server. This script reads the last 10 errors from the Apache log file and writes them to a text file called last10errors.txt. This can help you quickly identify recurring issues that may need fixing, like configuration problems or broken links. Regarding the audio transcription tool, it seems to time out if left inactive, which means you have to restart it every time. You're aiming to address this by ensuring the tool continues transcribing without manual intervention, possibly by adjusting timeout settings or keeping it active through continuous speech detection. If you'd like to delve deeper into any of these scripts or need help refining the error detection processes, feel free to ask. The goal is to make your development workflow more efficient by focusing only on actionable errors and improving the functionality of the tools you're using.
Okay, so we might need some suggestions as to how we can improve the both scripts. So if you can give another paraphrase the explanation quickly, make it more engaging and fun, that will be great. So we essentially when I'm looking at the last 10 error text file output, yeah, they're not very meaningful. I mean, I could run them past the LLM again and try and get something useful out of it, but otherwise, no, the text file is not actually useful. Now, regards the original sitemap Python script, we know that it's not actually finding all the errors that are shown on the page. So I don't know if we do we have to do we actually have to look at the server log, or can we just check the site directly? Okay, the transcription is not great again. I don't know what happened. Well, maybe it will still understand what we are talking about. The only way to find out is actually to restart this one again.
It sounds like you're juggling several tasks with these scripts and finding some of the outputs less useful than you hoped. Let me summarize and make it a bit more engaging. For the Apache error log script, It currently grabs the last 10 errors from the server logs and writes them to a text file, but it seems like the output isn't very meaningful. To make this more effective, you could try running these errors through a language model to extract more actionable insights. However, if the errors are still too vague or generic, it might be time to refine the script. Consider filtering out common, unimportant errors or grouping similar errors to highlight trends. This would help you focus on the issues that matter most to your development. For the sitemap script, it checks your website for errors, but isn't catching all the ones visible on the page. You might enhance this script by adding more sophisticated checks, such as deeper HTML validation or monitoring specific elements that frequently break. Alternatively, you could make direct API calls to the server logs or error monitoring tools to cross-check against the errors found on the site, ensuring that nothing slips through the cracks. As for the transcription tool, it seems like it's still a bit hit or miss. Sometimes it understands what you're saying, and sometimes it doesn't. If it keeps timing out or not capturing your speech correctly, try adjusting the timeout settings or incorporating a background noise threshold that keeps it active. The goal here is to keep the tool engaged without having to restart it all the time. In short, you have a few options to make these tools work better. Refine the scripts to filter or categorize errors more effectively, enhance the sitemap checks to catch more nuanced problems, and tweak the transcription settings for a more consistent performance. If you need more tailored advice on how to implement these improvements, I'm here to help.
Okay, so couple of things. Yeah, we might come back to this audio transcription and speech analysis tool later on. Same about the webcam eye tracking system. So it didn't sound like you had any specific or useful advice about checking errors on the site. We want to keep it to something basic. We might actually continue checking it manually. So actually, how about we just go over the website pages in a manual fashion. How does that sound? It's crazy that I'm copy pasting back and forth. It's asking me questions now.
It sounds like you're leaning towards a more hands-on approach for checking the website pages, which makes perfect sense if the automated scripts aren't catching everything you need. Manually going through each page could help you spot errors or inconsistencies that automated tools might miss, especially when dealing with visual elements, specific content, or subtle performance issues. If you're up for a manual review, you could create a checklist of the key elements to look for on each page, like checking for broken links, missing images, content formatting, page load times, and any visual glitches. You could also keep an eye on the console in your browser's developer tools to catch any JavaScript errors or network issues that might not show up directly on the page. While it might take more time, this approach could give you a much clearer picture of what's working and what needs fixing. You could even log your findings in a shared document or spreadsheet, making it easier to track which pages have been reviewed and what issues were found. How does that sound? Would you like more suggestions on how to make this manual review process smoother or more efficient?
Okay, are you still transcribing or not? Yes, we are. So that's great. Okay, we'll go over the website manually. We would like to eventually automate testing of the site. I thought we already have it in this Python code, but we might have another version of the website test. We might actually include combine testing the website and looking at the log for the server. Might actually combine the two strategy into one Python script. But yes, while we're doing it, we need to confirm that it's working correctly anyway. So we might as well do it manually and then try and automate the process. So do you want to summarize that quickly, or shall we continue? Shall we just dive in to the website? You have all the links in the XML provided above. I believe I'm copy pasting like this, but just things don't always work as expected.
It sounds like you're planning to manually review the website first to identify any errors or issues, which is a great way to get a clear picture of what's happening on each page. This will also help you confirm whether your current Python scripts are working correctly or if they need improvements. Once you've manually checked the site and gathered enough information, you can start thinking about automating the process. For automating the testing, you could aim to combine two strategies in your Python script: checking the website pages for visible errors and cross-referencing these with the server logs to catch any hidden issues. This combined approach should provide a more thorough error detection system. For now, though, let's dive into the manual review. You can use the links from the XML file above to visit each page, check for broken links, missing content, and other issues, and log what you find. Once that's done, you'll have a solid foundation to develop a more comprehensive automated testing script. Shall we start with the manual review, or is there anything specific you want to focus on first? Let's start the manual review by going through each of the pages listed in the XML sitemap you provided. Here's how we can proceed to ensure a thorough check. 1. Open each page in your browser. Begin by opening each URL in the list, starting from the top. As you navigate through the pages, check for any visible issues such as broken links, missing images, incorrect content, or layout problems. 2. Use developer tools for further inspection. Utilize your browser's developer tools, usually accessible by pressing F12 or right-clicking on the page and selecting Inspect. Look for console errors, network issues, or any failed resource loads that might not be immediately visible. 3. Check for HTTP status codes. Make sure each page loads without returning errors like 403, forbidden, or 500, internal server error. For example, the NiftyView and ECOG pages returned errors in your XML, so double-check these to see if they are accessible or if further investigation is needed. 4. Test interactivity and functionality. Interact with any tools or games on each page to ensure they are functioning as expected. For example, try using the Cardio Rock game or the Brain 3D viewer and confirm they work correctly without glitches or unexpected behavior. 5. Document your findings. As you go through each page, make notes of any issues you find. You can document these in a shared document or spreadsheet, categorizing them by page URL, issue type, and potential fixes. 6. Prioritize issues. After you've completed the manual review, prioritize the issues based on their severity and impact. This will help you decide which problems to address first and streamline your efforts. 7. Plan for automation. With the findings from your manual review, start thinking about how you could automate these checks in the future. This could involve improving your existing Python scripts to catch more specific errors, or integrating new tools that can automate visual checks, like browser automation libraries, e.g. Selenium or Puppeteer. If you're ready, we can start with the first few pages in the list and go from there. Feel free to let me know if you want guidance on a specific page or help with a particular issue.
You're suggesting doing the nifty view, but we had some serious issues with it. I think the libraries we were using for it are a bit broken. So we might not use that one for now. What was the other one? The ECOG. Yeah, we're having an internal server error. Yeah, we can look at that one quickly. Well, essentially the XML is not quite correct because we already had a few other tools that are also broken, but for some reason, again, as I mentioned before, the Python script is not finding the errors. So I'm sharing below the index HTML. Just for your reference, and you can find the under the development section. So yeah, we probably wouldn't like to focus on those. Yeah, but before we do that, or while you're generating responses, we might actually showcase other tools that are actually working. Yeah, we had this speech recording error. That's a bit odd. I don't know when I got it, just randomly. It happens with other tools as well, so I'm not it's something common. Yeah, I'm not sure why we getting that error.
It sounds like we should focus on a manual review of the website pages, particularly those flagged in the XML and any others that are known to be problematic but were not detected by the script. Since you mentioned having issues with the libraries for the Nifty View page, we'll skip that for now and prioritize the ECOG page since it returned a 500 error code, indicating an internal server error. Here's how we can approach this manual review. 1. Start with the ECOG page. Navigate to the URL hts/bioneos.com/ecog and check if it displays the page correctly or returns an error. If there's an error, note down any visible error messages or broken elements on the page. This information will help determine whether the issue is related to server-side code, such as a missing library, a syntax error, or a misconfiguration. 2. Check the browser console and network tools. Open the developer tools in your browser, usually available by pressing F12 or Ctrl-Shift-I. Go to the Console tab to see if there are any JavaScript errors or warnings. Check the Network tab to see if any resources, like scripts, style sheets, or images, are failing to load. This can help identify if the 500 error is due to a missing or corrupted file. Harb 3. Review the server logs. Look at the server logs, especially the Apache error log, /var log /apache2/error.log, for any error messages related to the ECOG page. You might find specific error messages that give clues about the root cause, such as a missing module, permission issues, or script errors. Hasher 4. Fix any obvious issues. If the server log or browser tools reveal any clear issues, such as missing files or broken paths, try fixing these directly. For example, if there's a missing library or dependency, ensure it's installed and accessible to your server. 5. Repeat for other known broken pages. After addressing the ECOG page, move on to the other pages in the XML that have known errors or that were manually identified as problematic. 6. Consider combining the checks. Once the manual review provides more clarity, consider combining both server log analysis and page checking scripts into a single Python script. This combined script can check for common server-side and client-side errors, making it easier to identify and fix issues going forward. Would you like to start with these steps on the ECOG page, or is there another page you prefer to start with?
Okay, so we should be still transcribing. This one is still working because we didn't get that error message yet, which is great. I have no idea why we're getting an error message for the transcription thing, but that's not what we are currently focusing on, so that's okay. So we opened all the under development pages. Yeah, we have a few. Okay, let's start from the end. So the Tiny Doctor currently it's working fine, but it's just really bad because we were not able to generate realistic body parts to be used in the game. Yeah, we also have this problem of Google placing its related search topics in the middle of the game, so we want to prevent that from happening anywhere across the site before we actually, yeah, we don't want to turn off essentially the ads, the advertisement on the website yet, but yeah, we want to prevent the ads from displaying anywhere on the first visible page. We only want them when scrolling down the page. This is because the first page is where the tool canvas is. Okay, so we also have the cardio rock that we were working on yesterday. We're actually pretty happy with how it's working. Yes, we need to do a video on it explaining what it actually does, even though there is an explanation at the bottom of the page, but it's not complete at the moment. Yeah, we might have to rewrite the text. We also need to add the logo and the drop-down menu as we have on all the pages on the site to the cardio rock, and we should be ready to move it outside the under development section. And yes, we will continue testing it, but if you can test it for us as well, that would be really nice. Yeah, the ecog page is just returning an error at the moment. Failed to load resources. That's not good. It's something to do with the Flask. The Flask app. It might be to do with the fact that in some of our code, we need to distinguish between calling get requests, HTTP requests locally as opposed to in production. So it's actually might be working on a local server but not in production. This is another check that we need to do essentially for all the tools. We need to make sure they work both in production and on the local server for further development. Oh, we got this speech recognition error again, a network error, so it's not transcribing. Yeah, I'll just continue from here. We wanna, how about, can we fix them all? Can we fix them all at once? Wanna fix all the tools at once. So yeah, while we doing this, go check out the site. Yeah, we'll be fixing some things on it. We have ethics that just blocks brain and EEG. The rhythm scan was the last tool. It's actually us training a model, not just using AI, but actually doing AI. This is 600 images in train, test, validation. The validation and testing has only 30 images in each folder, and train has the rest, 600 images all up, labeled with seizures and not seizures. And we run training of a convolutional neural network 10 times, and on this page you can see the results. So it doesn't allow you to train, but it does allow you to go through the results and see what we get. We stopped at 10 not because it's a nice number. Yes, it's also a nice number, but also because run 10 gave us a worse results than run 9. So you can see it clearly in here. We had 6 misclassified images in run 10 and only 2 misclassified images, spectrogram images in run 9. So that's when we stopped, and you can see also the accuracy, model accuracy and model loss saturating at pretty high and pretty low values. The confusion matrix is pretty good. We didn't get any false alarms and only 2 false negatives when it's actually a seizure, but the prediction indicated non-seizure. So we got eventually to 96.67% accuracy. and then it dropped in run 10 of the training, it dropped to 90%. You can see all the explanations at the bottom of the page. Yeah, go check it out. And the data, just so you can see, what's the actual training set. I think if you go to one of the validation ones, so that's an example of no seizure. I don't know, there's some noise in there. There's essentially nothing in it in a seizure spectrogram of the EEG. So this is converting time series data into a spectrogram image, into an image data. We can see there's that pattern there on which hypothetically the convolutional neural network is being trained on. I'll be very surprised, and this is something we actually need to check, that it's not actually training on something else, like the size of the image or some noise in it. We actually somehow, next stage would be confirming that this neural network is actually training on that difference in the image, being the seizure spectrograms have this pattern in it. You have slowing down of spiking activity during an epileptic seizure, and a non-seizure spectrogram does not have that pattern. Yeah, you can see it kind of clearly in there as well, except it having some noise too. So that's what we need to check out with this one. So this is in the brain and EEG section. We of course have the EEG to music converter. Go check it out as well. You would love it. And provide your feedback. I haven't touched it in a while, but yeah, if there's anything that needs to be done to it, to let me know. We have all sorts of other things on the site. Most importantly, I forgot to mention, is that the rhythm scan has at the bottom of the page, you have some advertisement on it, which I probably shouldn't be showing in a YouTube video because it's now monetized, but this is still Google Ads, and YouTube is also showing Google Ads, so that's probably okay. Let's see how we go with that. Anyway, the page has an appendix at the bottom that has all the Python code that is required for training this model. So this code, well, worked a couple days ago. So if it stops working after a while, then blame. There's a video of me actually running it, developing it. Check out other videos on the channel. And this using TensorFlow, Keras, and sklearn for generating the confusion matrix. A matplotlib for plotting the data. Don't remember what Seaborn SNS was used for. Yeah, we have an image library. Yeah, so if this code doesn't work for you, then it's probably because you are not something changed with the libraries. And that actually reminds me a good point that we actually have to include. We do have it on the site. The libraries we are using, so we are not running virtual machines. That's why I don't have the what is it you normally have? Is this still transcribing? No. Anyway, we'll go back to this. I'm losing my voice as
It
well.
sounds like you've made some progress in your manual review, particularly with the Tiny Doctor and Cardio Rock pages. Here's a quick breakdown of what you've identified and some suggestions on how to address the issues. 1. Tiny Doctor page, improving realism and handling ads. Body part images. Since the game is currently using unrealistic body part images, you could consider using open source anatomical illustrations or generating more accurate graphics using tools like DALL-E or other AI based image generation services. This could make the game more engaging and educational. Ad placement issues. To prevent Google Ads from displaying in the middle of the game, you can modify the ad settings in Google AdSense. You can set the ads to only appear after the first scroll or in specific areas of the page by adjusting the ad placement configuration. You might also consider using the anchor ads or vignette ads formats, which are less intrusive and do not appear directly on the content area. 2. Cardio Rock page, finalizing content and design. Explanation content. Since the current explanation at the bottom of the Cardio Rock page is incomplete, start by expanding it to clearly describe the purpose of the tool, how to use it, and what the user should expect in terms of results or interaction. This content can include a simple tutorial or step-by-step instructions. Logo and drop-down menu. Add the logo and drop-down menu to match the design of other pages, ensuring a consistent look and feel across the site. This will improve navigation and make the site more user-friendly. Video content. Create a short, engaging video that explains the purpose of the Cardio Rock tool and demonstrates its use. This will provide users with a clearer understanding of the tool's functionality and encourage more interaction. Consider embedding this video prominently on the page. 3. Moving forward with under development pages. Once you've made these improvements to the Tiny Doctor and Cardio Rock pages, consider testing them again to ensure the changes work as expected. After that, you can decide to move them out of the under development section and into the main sections of the site. It seems like you're making good progress, and these changes should help improve the user experience on your website. Would you like to focus on these specific adjustments, or is there another page you want to address next? Your YouTube channel, BioniChaos, looks great. It has 617 subscribers and over 621 videos, which is an impressive amount of content. The channel focuses on advanced biomedical research, especially EEG data analysis, and offers viewers a variety of videos, such as tutorials on removing noise from EEG signals using wavelet transforms and linking Visual Studio Code with ChatGPT-4 for live coding. Your channel banner, which integrates the BioniChaos name with an ECG waveform, visually conveys your biomedical focus effectively. Additionally, you provide a clear call to action for viewers to subscribe and join, along with a link to your website and Patreon for further support. It seems like you are actively engaging with your audience through project updates and tutorials, and the presence of the subscribe and join buttons further encourages community building and viewer engagement. Great job!
Yeah, we're getting an error for the speech recognition network. Looks like yeah, I have to restart this page for it to start transcribing again. I don't know why we're getting the following error as appears above. Hey, do we need to move this tool into the under development section as well? Or not? Because I mean, it is working, it's doing something useful. It's transcribing voice, giving you metrics. I think the transcriber status must be wrong because yeah, when we're receiving that error, the status obviously should be off because it's not transcribing anymore. But yeah, can we fix all these problems all at once with all the under development tools and this audio transcription tool as well? Probably not. So we have the rhythm scan is working great. Ooh, that's not good. It's again placing the Google ad stuff in the middle of my content. We do not like it at all. Should be some sort of simple solution for it in the HTML. What's currently the HTML looks like? Yeah, it will have that script in the middle of the page. Which we really do not like. A Control Shift C. Yeah, this one. Don't like that auto widget being in the middle of our results. Big no. And the image is fine. Autos widget. We don't want to copy element, we want to copy the whole page. How do we select it? You're still transcribing, yes. Yeah, this is obviously a separate issue. Okay, I'm having even trouble selecting the whole thing. This tool was trying to make sense of this Kaggle competition data, but it's not working. It's having trouble fetching the data. From memory, the problem began when we actually reduced the data size, the dataset size, to something more manageable. Because the actual thing is 26 gigabytes, but we essentially took just a small sample of it, so we can work with on the page and display on the page. So if we can troubleshoot this some more and figure out what's going on, probably be easier just starting fresh. If you do, let me know what you think about that. We have this structure tree. So if we run that, yes, we're getting errors like this one. Like the one indicated above. And we have it's a Flask application, so we have this backend code. And there's something wrong with it, is there? No, this is just indicators for Git. It's got Git management, whatever, but we're not actually using it at the moment. We're doing our own version control. Fortunately or unfortunately, depends how you see it. Yeah, if you have any comments, do let me know what you think. I'll be sharing the code with you next. We would like to quickly fix this one. Yeah, it's not transcribing anymore. To keep refreshing, we have to keep refreshing this page. That's okay. Yeah, we'll do that later. Restricting ad placement, modify HTML, prevent mid-content ads. I don't think that will work. Checking transcriber styles. Yeah, this is another application. We will get to it a bit later. So we have this error fetching the code because the file resource is not found. We don't actually have that file. Yeah, maybe that might be misfigured. Okay, thing is, if we stop this application for a second, we have in info text, we have this script for the bash that will place all the current structure of files and folders into a structured text file. So I'm sharing that one with this message. If you can have a look at it. and we need to make sure the code is working with this specific file and folder structure. We need to include sections of the code that actually check which EEG IDs are present. So the problem, the main problem is that the train CSV has all the data, but we have a small subsection of it. So maybe we need to generate an updated train CSV file for the reduced dataset, just so the web application, the Flask application works and showing data. We also have the JavaScript can you give a continuous sentences, full paragraph summary of the changes that are required in the code?
To resolve the issues with the Flask application, you will need to create a new train.csv file that matches the reduced dataset by scanning the train EEGs directory and generating an updated CSV that only includes the EEG files currently present. This change is necessary because the original train.csv still references the full dataset, causing errors when the application tries to access missing files. Once the new CSV is created, you should update the Flask routes in your application to reference this new train_reduce.csv instead of the original. Additionally, enhance error handling in the code by providing more detailed logging and clearer error messages, which will help identify problems in the future. Double-check the directory paths used throughout the application to ensure they are correct, and confirm that all files have appropriate read permissions set. Finally, test the application thoroughly to ensure that all routes function as expected with the reduced dataset. And consider implementing improvements like caching for frequently accessed data to enhance performance. These changes should address the current issues and make the application more robust and easier to maintain.
Okay, so we are adding this new, what should we call it? What should we call this Python script? Check files by. Okay, we need to stop the web application for a sec. Yep, this train reduced has 749 entries as opposed to, yeah, the original train that has gazillion. When we get the GIDs, oops, get the GIDs instead of train CSV, we use train reduced CSV. That sounds legit. Comment that one out. Everything else should be the same. Here we do want error handling, but we also want something running straight away. Right. Okay, so we actually see the EEG data now. But is this still transcribing or not? Well, obviously not. We don't have recognition ended. That's not even an error, that's just a warning. Yeah, okay, so now we have the EEG data is being displayed correctly. However, okay, the sub IDs, they need to come from the same file as well. So instead of train CSV, we want to replace it with train reduced CSV. Here, there. Yeah, just leave that one that is commented out anyway. Let's try that again. Should display something on the get-go. So network. Yeah, right. So we have the EEG, we have it on different channels. Have the patient ID. Also, where are the spectrograms? Using train reduced. Train reduced. Guess something else is wrong. Something else is wrong. So fetch EG data. Yeah, we would like more error handling there. That's for sure. know why do I need to select an EEG ID. Yeah, something wrong. Still wrong with that one. Yeah, I'm not getting any useful errors, am I? But we should be displaying Ctrl+Shift+C. Yeah, we have also 4 spectrogram canvases that meant to be showing data. Okay, I also meant to have 4 spectrogram canvases that are showing data. We can look at the image attached and let me know what might be going wrong. Just the text, continuous sentences and full paragraphs at the moment. We will be fixing the code later. I'll be also later sharing the current version of the code that we have. Thinking, should we have our own chat, chatbot working on the side? Could be just working with this one. They have our own version of it.
From the image, it appears that the Seizure Fuzz EEG data viewer is not properly displaying the spectrogram data on the 4 spectrogram canvases as intended. The main issue seems to be related to missing resources, such as the logo image, BioniChaos images logo.png, and the style sheet.
For us to be able to display the spectrograms as well, we need the spectrogram ID and spectrogram sub ID. And those are not being fetched correctly from the CSV file. Just focusing a bit on the wrong thing. So here is a sample of this is the beginning of the CSV file. We need to be able to parse it correctly. Currently the EEG ID, electrode and patient ID are being retrieved okay, but the spectrogram ID and spectrogram sub ID are not. Yeah, let's focus on the image attached. We need all these drop downs being populated.
From the screenshot and the sample CSV data provided, the issue seems to be related to properly populating the drop-down menus for the EEG sub-ID, spectrogram ID, spectrogram sub-ID, and spectrogram label offset seconds fields. While the EEG ID, electrode, and patient ID fields are being retrieved correctly, the remaining fields are not. To fix this, we need to ensure that the backend Flask API endpoints are correctly fetching and returning the required data from the CSV file, and the front-end JavaScript is correctly processing this data to populate the drop-down menus. 1. Backend issue. The Flask API routes responsible for fetching the spectrogram ID, spectrogram sub-ID, and spectrogram label offset seconds may not be properly reading the CSV file or extracting the necessary columns. We need to check that these routes are correctly parsing the CSV and filtering the data based on the selected EEG ID or other parameters. Specifically, the /get spectrogram ID, /get spectrogram sub ID, and /get spectrogram label offset routes need to ensure they return the correct values from the CSV. 2. JavaScript issue. On the front end, the JavaScript functions that call these API endpoints and populate the drop-down menus may not be handling the received data properly. For example, the function populating the EEG sub-ID dropdown is displaying object instead of the actual value, which indicates that the function is not correctly interpreting the data format. We need to ensure that the JavaScript correctly parses the JSON response from the backend and extracts the appropriate values for each dropdown. 3. Ensuring correct API response. Each drop-down population function should handle the corresponding API response correctly. This means checking the data structure of the response to ensure that the options added to the dropdown match the expected format. For instance, if the response is an array of objects, the function should properly extract and use the relevant properties, e.g., item.spectrogram_id or item.spectrogram_sub_id. To summarize, the solution requires validating that the backend correctly processes and returns the necessary data from the CSV file for all relevant endpoints. And the front-end JavaScript is correctly handling this data to populate each dropdown. Adjustments to both the Flask routes and the JavaScript may be needed to fix the current issues with the drop-down menus not being fully populated.
we have different folders for the train EEG and train spectrograms. Are you taking that into account or not? Someone is saying they are only into HTML. Well, unfortunately, yeah, HTML won't cut it. If you're only into HTML, you are after static pages with text and images only. That is not what we do here. So a bit unfortunate for you if you are only into HTML. We're essentially doing full stack, JavaScript, Python, HTML, CSS. Yeah, all of it is absolutely important, particularly in this case where we actually retrieve data from the server. So it's working more or less okay, except it's also meant to be showing the spectrograms, and I can't get them displaying correctly at the moment. So we are trying to fix that. So we're working with the reduced version of the original dataset, but the spectrogram IDs are not being populated for some reason. And I have to repeat all that because the transcription wasn't working and I can't type. So we'll repeat it quickly. We are saying that we are still getting an error. We might need to restructure, redo the whole code from scratch. How does that sound? Because we're getting the same error. So I'll share what we currently have. If you can generate the prompts first for regenerating the entire code base, that will be awesome. Keep in mind that the train spectrograms, the files, the Parquet files, are in a separate folder or in the data folder. So you actually have all the information. Maybe we shouldn't share the current code because it doesn't really fully works. We only share the image of the main problem being that the spectrogram ID, spectrogram sub ID, and the spectrogram label offset in seconds, essentially all the spectrogram data is not being populated in the drop down menus. So we need to fix that. Just rely on the image attached and let me know what you think. Should we regenerate the code from scratch or continue fixing what we currently have? Yeah, this is not fun when we're getting into the nitty gritty trying to fix this tool. Well, it's better than it was because it's actually displaying something useful.
Given the persistent issues you're facing with the current code, especially the repeated errors related to the spectrogram data not being fetched or displayed correctly in the drop-down menus, it may indeed be more efficient to regenerate the code from scratch with a more structured approach. This way, we can ensure that all the requirements are met, the structure is optimized, and the code is clean and maintainable. Let's go ahead with the regeneration of the entire codebase.
Okay, can you actually update the explanation for what was changed in continuous sentences, full paragraphs? Oh, because we can't convert this one to speech, can we? Don't want to be converting code into speech. That would not sound great, would it? Currently we have about 150 lines of backend Python script.
The regenerated code for your Flask application introduces several important changes that enhance its functionality and resolve the issues previously encountered, particularly with the drop-down menus not populating correctly with spectrogram data. The new code is designed to ensure a more modular and efficient structure, which makes it easier to maintain, debug, and extend in the future. One of the primary changes is the reorganization of the backend logic to use a single, centralized data load for the main CSV file, train_reduced.csv. By loading this file once at the start of the application, we minimize redundant file access, which can significantly improve performance. This change reduces the overhead associated with multiple file reads and ensures that all the data is readily available for any API endpoint that requires it. Each route in the Flask app is now designed to handle a specific data fetching task, such as retrieving EEG IDs, sub-IDs, consensus options, electrodes, patient IDs, and spectrogram-related information. This modular design improves code readability and makes it easier to manage data flow across the application. To address the problem with spectrogram data not being fetched or displayed correctly in the drop-down menus, new endpoints have been added. These endpoints, getSpectrogramID, /getSpectrogramSubID, and /getSpectrogramLabelOffset, are specifically created to fetch spectrogram IDs, sub-IDs, and label offset seconds based on the selected EEG ID and sub-ID. The updated routes ensure that all necessary data points are retrieved accurately and that they can be displayed in the user interface as intended. Additionally, an endpoint for fetching the actual spectrogram data, /fetchSpectrogramData, has been implemented to allow direct access to the spectrogram files located in the train spectrograms directory. This clear separation between EEG and spectrogram data management resolves the ambiguity of data handling from different directories. On the front-end side, the JavaScript has been updated to reflect these changes in the backend. The script now properly handles dynamic data fetching for each drop-down menu, using dedicated functions that are triggered by user interactions. When a user selects an EEG ID, the application will automatically fetch and populate the EEG sub-IDs and other relevant options, such as the spectrogram ID and label offsets. The front-end script has also been enhanced to include additional error handling, which provides feedback in the console if data fetching fails or if there is no data available for a specific endpoint. The error message you're encountering, get//get_spectrogram_ID/111488h /object sent to object http://811,500, suggests that the front end is sending an incorrect request to the back end, specifically with the object-to-object value instead of the expected sub-ID. This is likely due to an issue in how the JavaScript is handling the data that is being populated into the drop-down menus. Here is what is happening. 1. Incorrect data handling. When the drop-down menu for EEG sub-ID is being populated, the selected value is not being properly extracted or is being referenced incorrectly in the JavaScript. Instead of sending a simple integer sub-ID value like 0, 1, 2, etc., it is sending the entire JavaScript object representation object, object. 2. JavaScript issue. The issue lies in the JavaScript function that handles the population and selection of the drop-down values. When the value for the dropdown is set, it's likely that the code is using an object instead of extracting the appropriate property, which causes the front end to send object object to the back end. How to fix this? To resolve this issue, you should ensure that when populating the dropdown and sending data to the back end, you are extracting and using the correct values from the object. Here's a detailed explanation of how you can fix this. Update the JavaScript. You should modify the populate dropdown function in your JavaScript to handle the data correctly. Specifically, you need to ensure that the dropdown is populated with the correct value and text content for each option. Here's an updated version of your JavaScript. JavaScript document.addEventListener, DOM content loaded, function, const EEG ID dropdown equals document get element by ID EEG ID, const electrode dropdown equals document get element by ID electrode, const sub-ID dropdowns document get element by ID sub-ID, const expert consensus dropdown equals document get element by ID expert consensus, const patient ID dropdown equals document get element by ID patient ID, const spectrogram ID dropdown. Based on the provided CSV data, the main issue lies in how the JavaScript code handles and sends the data to the backend. The dropdown for EEG sub-ID is not properly referencing the sub-ID value, which is causing the front end to send object-object instead of the actual sub-ID. The backend expects a simple integer for the sub-ID, but the incorrect value is leading to errors. Here is the correct approach to extract the necessary values from the CSV data and properly populate the dropdowns in the front end. #. Corrected JavaScript. To fix the JavaScript code, ensure that the correct value is sent when interacting with dropdowns. 1. Ensure the correct object structure is used. When the dropdown is populated, make sure the correct fields, EEG sub-ID and EEG label offset seconds, are extracted and that their values are properly used. 2. Improved handling of sub-ID dropdown. Adjust the JavaScript to properly use the EEG sub-ID and ensure that the backend receives a valid value. Here's the updated JavaScript code. JavaScript document to add event listener, DOM content loaded, function, const EEG ID dropdown equals document.get element by ID, const electrode dropdown equals document get element electrode, const sub-ID dropdown equals document get element by ID sub-ID, const expert consensus dropdown equals document get element by ID, expert consensus, const patient ID dropdown equals document get element by ID patient ID, const spectrogram ID dropdowns, document get element by ID spectrogram ID. Const spectrogram sub-ID dropdowns, document get element by ID spectrogram sub-ID. The TypeScript error you're encountering, spectrogram.
I don't know why it's reading the code all the time. It's pretty annoying. It is pretty annoying. Why are you reading the code? Okay, but the even more important is that we are still not getting the spectrogram ID being populated correctly, and the main reason for it is actually that the EEG sub ID is not, it's still not being fetched correctly. Still not being fetched correctly. The object, I don't know why. Within the EEG sub ID, in addition to the object, we also have 1, 2, 3 ID. So it is being fetched correctly. when we select one of the numbers, the spectrogram ID is still not being populated. The transcription. We're not having much luck today, are we? Do we need to really prompt it, or can we just provide? Okay, we're getting a lot of errors. Yeah, pretty much all of those are actually important. I don't know if it's like working with a developer. Let me know in the comments. Is it like working with a developer? Hopefully working with a developer is much better. But why do I have a feeling that it is not?
The error you're encountering, get/get spectrogram ID /941874444 object 500 internal server error is due to a JavaScript issue where object is being sent as part of the URL instead of the actual value for the EEG sub ID. This typically happens when an object is inadvertently converted to a string in JavaScript, leading to the placeholder text object being displayed. Root cause of the issue. In your code, the problem seems to originate from the way you are accessing the values of the dropdowns. Specifically, when you call the populate dropdown function to fetch the spectrogram ID, you are passing an object instead of the actual value of the dropdown option. Solution: fix the JavaScript to access correct values. To fix this issue, you need to ensure that the correct value is being accessed from the dropdown selection. Here is the corrected code.
It's actually working better. It's still transcribing? No, I have to keep refreshing this page. It's really annoying. We have to, yeah, in another stream, in another live stream, we'll get to the audio transcription thing and actually improve it. Try to improve it. There's something with the libraries that we're using, so there might be no way to actually improve it. Okay, moving on. So now we have the EEG sub ID being populated correctly. However, the spectrogram ID, spectrogram sub ID, and the spectrogram label offset in seconds are not showing anything. They're not being populated. They're meant to be taking the data from the train reduced CSV file. That's obviously not happening. Any suggestions are more than welcome. Yes, now we have the EEG sub ID being populated correctly. Why can't get my voice? How this the spectrogram Yeah, see the image attached. See image. Yeah, page and ID we should not be able to change it, because that's actually coming with the EEG ID. So that should not be an input, that should just be an output. Need to ensure correct Flask API endpoints. Well, yes. Why didn't we get it to begin with? So we have 145 lines of code. No. Okay, that's wrong. Okay, this is what we currently have. Can you help us integrate the new changes, the new bits to the code into what we currently have? Sure, spelling mistakes are okay. Okay, now is it updating the whole thing, is it? By the way, while it's generating the live sessions meant to be interactive. So if you have any questions, comments, you check especially if you check the website, and you have any thoughts, ideas, suggestions, complaints, do let me know. That's why we're doing these live streams, is that we can address them straight away. Go actually check out the site. You will be helping the project that way. We also, by the way, have a join button, so you can actually support the project financially as well, if you like, on Patreon, but also now the YouTube itself allows you to join as a member to the channel. So it's another way to show your support. Thank you in advance. Let's get back to this.
Certainly. Let's integrate the necessary changes into your existing code to ensure that the spectrogram ID, spectrogram sub-ID, and spectrogram label offset seconds dropdowns are properly populated from the trainreduce.csv file. Updated Flask code will
So we currently have 145 lines of code. There's still 145 lines, which is a bit suspicious, but okay. We have the JavaScript updated as well. Currently we have 106 lines of JavaScript code. The new version has 107. Why do I have a feeling? Yeah, we get some errors on the server. This is the file and folder structure for the whole project. This is an example of the first 10 entries in the train reduced CSV file. Do you actually need me to explain what each thing is, or it's not transcribing? Well, let's just try without my biased explanation. Yeah, we obviously might be going in circles because well, I don't know why. Restart the Flask application. Is that actually necessary? Reload the web page, select options. Yeah, reloading with Control F5. Still getting the same thing. Select options. Monitoring console. Okay. We haven't updated JavaScript. 107. 108. Okay. We're actually in business. We are in business. Yeah, we need a transcriber. Okay, we're actually in business. We're getting all the values finally populating correctly. I think correctly. Well, they are populating. I don't know if they're populating correctly or not, but they are populating. So that's a good sign. So that's awesome. However, there's always a but, isn't there? The spectrograms are not being displayed. We are not getting any specific errors or anything in the console or the server terminal. Should say congratulations. Blah, blah. Great to hear. Okay. It's funny how getting this corporate speech from somewhere. Can only guess what's in the training set. While it's generating, we could, I don't know, do particle motion if you like. This could actually help you relax, by the way. This is how many projects and things you're juggling at the same time. And that's how if that's your brain, and those are the projects that you are juggling up in the air, then chaos will sound like this, like a seizure or something. But if you can well, so say even if you had unlimited number of projects up in there, you could still just slow them down. So that's manageable already, isn't it? So my brain is probably doing something like this at the moment. Let me know if what your brain does. I can obviously reduce the number of projects as well. I have like a few, say 2 or 3, but going super fast. That should also be, yeah, those are not actually affecting, only one of them is affecting your brain. The other two are just floating around. But yeah, there's a lot of tools like this on the website. Go check them out. You'll be helping the project that way. Let's get back to our
Great
era.
to hear that all the dropdowns are now populating with values. Since you mentioned that the spectrograms are not being displayed, even though the values are correctly fetched and there are no errors in the console or server terminal, the issue likely lies in how the spectrogram data is being handled and visualized on the front end. Debugging and fixing spectrogram display. 1. Ensure spectrogram data is loaded. First, confirm that the spectrogram data is being correctly loaded from the backend. Check the function fetch spectrogram data and make sure it is returning the appropriate data from the .parquet files. 2. Verify the JavaScript fetch for spectrogram data. In your JavaScript code, ensure that you're making a request to fetch the spectrogram data after the dropdowns are populated correctly. You should check if you are calling the Fetch Spectrogram Data API endpoint and handling the response correctly. If you are already calling it, make sure you are receiving the correct data format. 3. Update the JavaScript to fetch and display spectrogram data. You may need to modify your JavaScript to request and display the spectrogram data. Here is an update to your code that includes fetching spectrogram data and rendering it. JavaScript document.addEventListener DOM content loaded function. Const EEGID dropdowns document get element by ID EEGID. Const electrode dropdowns document get element by ID electrode. Const subID dropdown document.get element by ID subID.
Okay, why are we trying to load spectrogram files that do not exist? Okay, I think I know what the problem might be. Let me check the folder. Containing folder. Yeah, this file, for example. Yeah, this is super weird. Yeah, the problem I think is that when we reduced the dataset, I think the problem is that when we reduced the dataset, we now have like an unmatched set. So for the EEG IDs that we have on the list, we might only have the train EEG, but not the train spectrograms. So when we reduce this stuff, 353733, we need to make sure we have a matching set. So that's a problem, isn't it? What we can do is try and load. Let me see if we have it. So this is what it's called: HMS, harmful brain activity classification. I think we just move it into backup, so we might not even have it on this on the server anywhere. There is only one way to find out. Okay, we have the zip version of it. Yeah, it's 20 gigabytes. But that might solve the problem that we are having. Yeah, still have it in the downloads folder. Should we just move it in? Considering. Let's see how much space do we have. Yeah, we should have enough space. Let's see how long will it take to extract it. Yeah, about a minute, couple minutes. A couple minutes to extract the dataset. Well, at least now we know what the problem is that we don't have a matching file in the spectrogram folder and the EEG folder. Yeah, still waiting. It will take about a minute or so to extract the whole data. It's about 20 gigabyte of extracted file. Yeah, we could check verify matching sets. We can run it while it's extracting. The result will not be good. Yeah, we can stop the application for now. EG files with no matching spectrogram. Yeah, we got a bunch without a matching spectrogram. That's not good. Okay, let's move. Yeah, let's actually delete what we currently have and move the new stuff. And we should get rid of the train reduced. Okay, we should get rid of the train reduced. Okay. Okay, bear with me. Bear with me, bear with me. Okay, we're deleting that. And placing this. This will take 5-10 seconds or so to copy. Now the thing is, okay, we don't have the data set. This description is on the page. We might save it, save as. That's a description. You just pop it in to the main folder here. A train reduced we don't need anymore. But we need to change all the calls to the CSV file. Hey, we're not using train reduced, we're using train CSV. Hey, verify matching sets. Okay, we have a much longer list now, as expected. Well, yeah, it's too long, so that code is kinda useless. Yeah, so the uncompressed data folder is 26 gigabytes. Should be okay. Just remove it from the download folder. Python script is the checking Python script is not very useful because it's like producing too many files. Yeah, just too many files in there. If you can return a print yes matching or no matching, perhaps it will be better. Or just ignore it for now. Okay, we're not getting any errors, but the spectrogram is not showing. Oops. Okay, the spectrogram ID. Popline drop down. Okay, spectrogram ID. Okay, fetch spectrogram data. Fetch spectrogram data. is actually returning 200. But it's not being displayed. It's not being displayed on the front panel. We are not getting any errors in the terminal. Everything is working correctly. The EEG data is loading well. All the drop downs are being populated. However, the spectrogram data is not being displayed. Can we make sure that the JavaScript code is currently working? But can we make sure the HTML script is okay and will work well with the JavaScript code? So mainly focusing on the ID names. It's ID name, spectrogram ID. Yeah, the spectrogram canvas is not present in the JavaScript. Yeah, that's right. Let's carefully examine the IDs. Updates are needed. Okay. Okay, spectrogram division element, but there are 4 of them. Why wouldn't this HTML just display 1? So am I getting rid of the spectrogram canvas? I might need help integrating the code. Okay, I might need help integrating the code so we know what the problem is. The original a spectrogram canvas left, right, are not actually present in the JavaScript. So the JavaScript is not populating them. Do we need 4 of them or will 1 suffice? I mean, the data has 4. Yeah, we have different electrode sides. We might need to also update the HTML with the description of what is it we are looking at. This is the uh, more accurate description. Okay, this looks much better. It displays spectrogram data, so we're displaying these 4 spectrograms. Spectrogram diff. Okay, there's no warning. Let's restart the Flask application. They are not actually showing. There are no errors whatsoever. Fix this style shit, do we? Do we have a CSS? Yeah, that's the generic one. Yeah, we shouldn't actually have. Yeah, we have a generic CSS. What if we get rid of it for a sec? Okay, so we don't have any errors on the server. We don't have any errors in the browser. However, the spectrograms are not showing. data structure. We have the data structure in a separate file. Wait, but this will be not updated. This has 214 lines of code, whereas structure, I'm not sure if we should even run it there, because currently we are using the full dataset and we'll have too many files. Yeah, it has yeah, this many files. So will it work with the current file and folder structure? Okay, we're trying to paste. It's only 28,000 lines of text. Oh, someone is struggling quite a bit. Struggling quite a bit. Snap. Just me snap ChatGPT. Okay, we don't have to load all that. That's okay. We will play nice. We will play nice. Okay, but we are trying to generate the structured text file for the whole project, all the files and folders. But currently there's too many of them. So how about we just do the general structure, and as far as Parquet files go, just include the first 10 in each folder that has them. How does that sound? Stuff that Parquet, didn't it? Okay, okay, let's generate structure. Tree. Can we just do it in a bash file command? We don't need the file for it. Can we just have the single line bash command? We don't need a file for it. Okay, if you say so. Put in info text. Do we need all of it? Let's check a structure. Okay, this is a structure. Well, we were trying to fix the code, weren't we? We were trying to fix the fact that the spectrograms are not showing. You said there might be issues with the structure for the project. So here it is. Can we fix the code? Okay, so in the HTML, yeah, we have that bit that looks the same. And in JavaScript, I have this display spectrogram, currently 112. Okay, 123. What? Make sure fetch spectrogram data endpoint matches the structure expected by your JavaScript. So those are fetched correctly, I'm pretty sure. Let's run the app. Yeah, we're not having much luck. We did do quite a bit of progress. I mean, before it wasn't displaying any data and the drop downs weren't populating. We solved that. 144. Fetch a spectrogram ID. So we're looking in the wrong place. Have 80. Unknown electrode. What? The electrodes seem fine. So we have fetch spectrogram data. Let's go network. So this one's working okay. And this spectrogram. And the spectrogram is okay as well. Pretty print. Pretty print. Is that meant to be pretty print? Which one's pretty? Ah, okay. Is this the G data? The spectrogram data? Electrode. No, that's not it. So if this is what I get for the EEG data, that's what I get for the spectrogram ID. Okay, I'm losing patience. I'm losing patience with the robot. Can you solve this? Yeah, the display a spectrogram. Here we have a data object. $124. You're having an issue with JavaScript. Issue with JavaScript. This is what we have for the code. And this is what we have for the output. Here's some more. Oops. Yeah, we're getting this error. Can you just fix it for us? I think we're close. Famous last words. We're always close, aren't we? Yeah, now the other problem is that when we're dealing with the whole data set, it's becoming less responsive as well. Okay, so we have the fetch spectrogram. Let's get rid of it for a sec. And we have display a spectrogram, append break. So these two functions have to go to be replaced. Okay, we have this fetched. We have the spectrogram data now. That's a good sign. A very good sign. There's no specific error. The spectrogram data is there, but it's not being it's not showing on the HTML. The spectrogram data is there, but it's not showing on the HTML page. Yeah, we're not passing it correctly. We're doing more trouble. Hey, more troubleshooting, are we? 131. Okay, we don't actually currently have the styling. We would like to have it within the HTML. So all the styling that is specific for this page, we would like to have in the HTML itself, because we do have a CSS code for the whole website, but specific components for this Flask application, the styling for them should be included in the HTML itself. So might need to fix that HTML page. No, we don't need that. Yes, we need this. So this goes inside the header, the head section. Don't know why. Could we have it? Could we just have it next to the element itself? So within the element of the HTML, within the same object, can we do the styling in line? Ooh, just correct the little tiny bit. Just wanted the styling to be just there. But don't generate the whole thing. It's annoying. Just focus on um, the spectrogram charts. Can you just focus on the spectrogram charts? Simple. Why overcomplicate things? Yeah, that's the one. That is the one. It's annoying. Okay, I have a good feeling about this one. It's actually understood what we meant. But this is not the whole code, is it? I have 171. What, are you joking? It's, it's essentially um, plotted the text. Just plot the text. This meant to be a spectrogram chart. It meant to be a spectrogram chart. How is it? Well, actually, it meant to be an image, so I don't know why. Why aren't we just converting it into an image to begin with? But okay, if we already have the frequency and power, well, then can we turn it into a spectrogram chart? Yeah, while it's generating, go check out BioniChaos.com and might continue this next time. Yeah, there's a lot of interesting tools. Go check them out. You will be supporting the project this way. This one doesn't really work well on mobile. You can draw your rocks and put water in it. It will simulate life. So I already discussed it many times before. I was running those simulations for a really long time. Go check out the earlier videos. What else we've got? Yeah, more relevant to what we're currently doing. Here we have those EEG viewers. This is just the time series data. But then we have other ones that actually show spectrograms. So that's what we expect from the current tool to show. This is a 10-second spectrogram and it looks a bit grainy, like low resolution. Should have better ones. Yeah, the difference between spectrogram and spectrum. A visualization. Got some error for the stream. I think because I was loading that tool. It's actually, yeah, I lost some frames. That should be okay. Now it should be back to normal. I still get that warning. Still get the warning.
To display the spectrogram data as an image or spectrogram chart, we need to use a charting library capable of rendering spectrograms, such as plotly.js. Since we have the frequency and power data, we can create a heat map where the x-axis represents time, the y-axis represents frequency, and the color intensity represents the power at each frequency time point. Step-by-step plan 1. Convert frequency and power data to a heat map format. We'll use the frequency and power data you have provided to create a two-dimensional array that represents the heat map. 2. Plot the spectrogram using Plotly. We'll use Plotly to plot the spectrogram as a heat map. This will allow us to visualize the data as an image where color intensity represents the power at each frequency over time. Hashtag updated JavaScript for creating a spectrogram chart. Here is the updated JavaScript code that uses Plotly to generate a spectrogram chart. JavaScript document.addEventListener, DOM content loaded, function, const EEGID dropdown equals document.getElementById EEGID.
Yeah, this is where a Plotly this must be a library issue. We are fetching the latest Plotly JavaScript, which actually has a 2021 indicated in it. What Plotly.js version should we be using for this? Make sure that this file actually exists. Okay, it's 2023. Yes, we did Control F5. Okay, we'll be having trouble integrating that. This is the code that we currently have. How do we actually... Can we just update the whole script that runs with no errors? Okay, we're obviously going in circles quite a bit. Go check out the website. There's a lot of interesting tools, and you will be helping the project this way. Yes, there is a human behind this. And by the way, if you want to join the channel, support the channel, you can now join on YouTube as well as the previous option on Patreon. Patreon. I don't know how to pronounce it properly. And we will be fixing all this stuff in the upcoming streams. So stay tuned. And let me know if there's any questions. Most importantly, pop them in the questions, in comments on any social media that you found this on. We are pretty much everywhere under the sun. Twitter, Reddit, Facebook, TikTok, Twitch, Discord, GitHub, Instagram. Yeah, I have some other websites as well. LinkedIn mainly, it's probably the best place because I actually use it for, instead of my like emails and stuff, I use LinkedIn, so I actually know, yeah, if you contact me on LinkedIn, I actually know who you are, because you obviously have an extensive information available in your profile. Shall we leave you with some music or something? Oops, this was the wrong simulations. Yeah, gesture music. It's loading for some time. Can't really. Just something to relax. There's actually two notes, two scales, musical scales. One is more annoying than the other. And you get longer notes, shorter notes, you get volume up and down, and you get the full scale. So I wonder if you're a musician, go try this out as well. Or if you just want to create music with essentially two musical instruments, because you have one for each hand. Yeah, good luck with this. Good luck creating. Did the robot do something useful? It generated a lot of code. Yeah, we need to make sure we're passing the EG spectrogram data correctly. Mismatch data, debugging. Yeah, so essentially doing more debugging. Yeah, this might take a while. Stay tuned. Where is, yes, script.js? That's what we are modifying at the moment. We have 180 lines of code. Suggesting an extra 7 lines. Are they going to be the lucky ones that actually solve all the problems? Maybe, maybe not. Yeah, we're having scaling issue. Can we get rid of scaling? have frequencies, we have power, we have time. Oops. How do we actually select
The image you provided displays different types of EEG signal patterns and their corresponding spectrograms for various brain activities, such as seizures, lateralized periodic discharges, LPD, generalized periodic discharges, GPD, lateralized rhythmic delta activity, LRDA, and generalized rhythmic delta activity, GRDA. Each of these signal patterns is shown across 4 different columns labeled as A, idealized, B, proto, C, edge, and D, edge, illustrating variations of the signal The frequency and power matrix dimension mismatch error indicates that the number of frequency values, sorted frequencies, does not match the number of columns in the power matrix. This mismatch can cause Plotly to fail when it tries to plot the data. To resolve this issue, follow these steps. 1. Ensure correct data preparation. Check that each row in the power matrix aligns correctly with the sorted frequencies array. Both should have the same number of elements, representing the power values corresponding to each frequency at each time point. 2. Fix data processing logic in JavaScript. Update the create spectrogram chart function to ensure that the data is properly aligned and consistent. Here is a revised version of the function. JavaScript function create spectrogram chart data. Prepare data for Plotly, const frequencies set equals new set. Use a set to collect unique frequencies, const times equals. Const power matrix equals. Determine the frequencies and organize power data, data.forEach entry index. Const row equals. Object.entries entry for each key power. Const electrode freq equals key.split if LLRL LP includes electrode. Const frequency equals parse float freq. Convert frequency to float if is nan frequency. Frequency set.add frequency. Add the frequency to the set row.push power. Assume power is a valid numeric value. If row.length 0, power matrix.push row. Add each row of power data to the matrix times.push index. Use index as a placeholder for time. Convert frequencies set to an array and sort numerically. Const sorted frequencies equals array.from frequencies set. Sort A, B equals A minus B. Validate power matrix dimensions. Const expected columns equals sorted frequencies.length. Const is valid equals power matrix.every equals row.length equals expected columns. If is valid, console.error, frequency and power matrix dimension mismatch, return. Plot the spectrogram. Const plot data equals x times y sorted frequencies z power matrix type heat map color scale viridis. Const layout equals title spectrogram. X-axis title time index. Y-axis title frequency hertz. Plotly.newPlot, spectrogram div plot data layout. Najnashar 3, explanation of the changes. Frequency extraction. Collect frequencies using a set to ensure uniqueness and sort them numerically. Matrix validation. Ensure every row in the power matrix has the same number of columns as the number of unique frequencies. This validation step helps catch any mismatches early. 4. Backend data validation. Ensure that the backend sends consistent data. Check that each entry in the response data has the same structure. The number of frequency points, sorted frequencies, matches the data rows you expect from your backend. 5. Testing and debugging. Log data lengths. Add logging before the error check to see the lengths of sorted frequencies and power matrix rows. JavaScript console.log frequencies, sorted frequencies.length, console.log power matrix rows, power matrix.length. Console.log power matrix columns, power matrix.map row equal row.length. This will help identify where the mismatch is occurring and what might be causing it. By following these steps, you should be able to fix the dimension mismatch and get your spectrogram chart to display correctly. From the console output, it is clear that there is still a mismatch in the dimensions between the sorted frequencies array and the power matrix. The sorted frequencies array contains 100 unique frequency values, while the power matrix has rows with varying lengths, 301, 400, etc. This inconsistency indicates that each row of the power matrix does not have the same number of elements as there are unique frequencies, leading to the dimension mismatch. Fixing the dimension mismatch. Let's correct the issue by ensuring that the power matrix aligns with the sorted frequencies. The goal is to make sure that each row in the power matrix corresponds to the same number of frequency bins, i.e., the length of sorted frequencies. Updated JavaScript code. Below is the revised create spectrogram chart function. JavaScript function create spectrogram chart data has to prepare data for plotly const frequencies set equals new set. Use a set to collect unique frequencies, const times equals, const power matrix equals. First, determine the unique frequencies data.forEach entry, object.keys for each key equals a const electrode freq key.split score. If LLRL LPRP includes electrode, const frequency equals parse float freq. Convert frequency to float if is nan frequency. Frequency set.add frequency. Add the frequency to the set. Slash convert. Your Flask application looks well structured, and it provides a variety of endpoints to fetch EEG and spectrogram data. However, there are a few areas where you might want to improve or refine the code to ensure it performs efficiently and correctly. Here are some suggestions to enhance your Flask server, addressing the most common issues and best practices. Improvements 1. Error handling. It is already implemented in your code, but you might want to add more context to error messages. The current error is due to a mismatch between the dimensions of the frequency array and the power matrix while creating the spectrogram chart. This issue often arises when the data is inconsistent or when the transformation from raw data to a structured format for visualization is incorrect. To fix this, let's make sure the power matrix aligns properly with the sorted frequencies and ensure that we handle any missing or undefined data points gracefully. Key issues to address. 1. Ensure all frequencies are accounted for. When converting the data into the power matrix, all frequencies must have a corresponding value for each time point, even if that value is null or zero or some other placeholder. 2. Check dimensions after filling the matrix. We should double check that the matrix's dimensions match our expectations after the transformation. 3. Adjust the power matrix generation. Make sure that each row in the matrix corresponds correctly to the sorted list of frequencies. Hashed updated JavaScript code. Here's an improved version of the JavaScript to address the issue. JavaScript document.addEventListener DOM content loaded function. Const EEGID dropdown equals document robustness against inconsistent data. The code is now more resilient to inconsistent data, ensuring all necessary data points are properly represented. By making these changes, your spectrogram should render correctly, assuming the underlying data is correct and consistent. The spectrogram data being fetched has a mismatch between its frequency values and the power matrix in the code, causing the plotting error you are experiencing. Let's focus on understanding the issue and fixing it step by step. Issue explanation. 1. Data structure insight. The data frame from your Parquet file appears to have columns representing different frequency bins, like LLs 0.59, 0.78, etc., for different electrode positions, LL, RL, LP, RP, along with a time column. Each row in the data frame represents a specific time point, and the columns contain the power values for different frequency bins and electrodes. 2. Plotting error. The error, something went wrong with axis scaling, suggests that when plotting the spectrogram data, there is a problem aligning the axes correctly because of inconsistent dimensions in the matrix being sent to Plotly for visualization. Problem diagnosis. The key problem is that while creating the power matrix for the heat map, we must ensure that each row of the matrix corresponds correctly to the frequency values, y-axis, for every x-axis time point. The issue seems to stem from how the data is being transformed and the final power matrix being created for Plotly. It is critical to align each frequency's corresponding power value at the correct index consistently across all time points. Solution: correct the data processing for plotting. Here's an updated JavaScript code to fix this. JavaScript updated code. JavaScript document.addEventListener DOM content loaded function. Const EEG dropdown document get element by ID EEG. Chart div plot data layout. Render chart in chart div.